So yeah, hey, thanks for having me up here. My name is Derrick Umali. I've been with Elsevier for 15 years now. I started with actually MDL, so I don't know if, I thought you looked familiar. I was like, yeah, so, it's been, when Elsevier had MDL and divested them in 2007, I actually went to the Elsevier side and they actually picked up Elsevier, transferred two of the products to the MDL products. It was Crossfire Beilstein at that time. And another product called Pharmapendium. So I'm in the life sciences division of Elsevier. And really, this talk was supposed to be given by the product manager, but he had to be flown back to Frankfurt to take care of sort of the migration. We're migrating Reaxys to this new Reaxys, and that's what I'm going to hopefully show you today. So our quick agenda, the history, where's Reaxys come from, the present Reaxys content today, indexing data, how we handle the input. So it's just a good overview of how we're getting this data into Reaxys. And then Reaxys searching. So as Effie showed you, talked to you about a little bit of how, I think in my bio, I think I probably have done the most Reaxys trainings out of the whole world. I don't know if that's a good thing or a bad thing, but I probably taught more people about Reaxys searching, and then really commenting, it's probably more about Marvin sketch drawing techniques as opposed to searching in Reaxys. So we'll talk a little bit about that. And then how Reaxys uses ChemAxon Marvin JS in building the database, and how it searches the database, how it renders the structures and the reactions in there. So a quick history. In Reaxys, we started when we incorporated Gamelin and Beilstein back in the early 90s, 89, 90, when those were put online and put on STN. We tackled first Gamelin and Beilstein and put that into the database. And in a quick overview of some of the milestones here, and some of the highlights actually of where I started with Elsevier. It's sort of quite exciting for me to see this. 2000, right? If any of you ever remember seeing Crossfire Beilstein and using that tool and the Crossfire structure editor, how far structure editors have come along. Back in 2007, 2008, when we started going to, me and Jürgen actually went to a few universities, a few customers, and beta tested Reaxys, really the move from Crossfire to Reaxys. We needed an online drawing tool, and I think Marvin Sketch was the one that we chose, the first one to implement in Reaxys. And I remember fighting myself and having to relearn how to use Marvin, ChemAxon Marvin Sketch, as opposed to ISIS Draw and things like that. And now moving on to sort of the newer Reaxys, where we're really promoting the ChemAxon Marvin JS, the component, just for the fact that a lot of folks are actually moving away from Java-based apps, right? So all the security issues, so we're really tying into ChemAxon Marvin JS as our structure editor. So a couple things too here. 2005 patent chemistry database was launched. That's where we started in Crossfire implementing experimental procedures. So if you search a reaction, you can see the experimental steps to recreate the reaction. It was implemented in the patent chemistry database. 2009, we transferred most of our customers to the web-based product of Reaxys. And then moving forward, we now have a current migration to the new Reaxys. And that's what I'm going to be showing you, how we're implementing sort of this current thought process of moving folks away from sort of structure reaction-based searching and maybe doing some intelligence behind the ways they search. So Reaxys today, it's a bibliographic database. A couple of core components here. Bibliographic database, we have over 54 million journal articles, million records in there from 16,000 journal titles. It's a substance database, 140 million substances. It's also a chemical reaction database, over 43 million single and multi-step reactions in the database. And it's also a property database. So a great thing about this is it's experimental properties. So a lot of a lot of companies use the experimental properties to sort of validate some of the models. So ChemAxon has these chemical calculators, these experimental properties coming from the journals, real experimentally excerpted facts coming from the journals attached to compounds. I've got 2 pointers here. We also have a Reaxys medicinal chemistry database. I think the next talk is off-target toxicities. So we also have a Reaxys MedChem. We've incorporated, it's a large bioactivity database in Reaxys, target database in there as well. So for those folks that do it. So moving on to the talk of how we get the data into Reaxys. Really starts from the published documents, patents, journals. We scan the chemistry space, about 400 core chemistry journals, manually excerpted. We're looking at it from the scientific model, compounds, structures and reactions, related properties there. That moves into our excerption, normalization, and the product is built. So the general overview, quality controlled at multiple levels, a lot of different checks. This database in Reaxys production, we put it out there and put check the database integrity as well. Quick database production slide, a workflow here. Really from when we get a document in hand, on average, document in hand to when we load it into Reaxys, on average, with all the excerption, which I'm going to go through, takes about 30 days. Right? So we actually take a lot of these documents, pre-process them, put them in a production database, distribute them to 4 or 5 different suppliers where they're manually excerpted by hundreds of scientists, the quality control, put back into the production database, exported out, and then made into this Reaxys database, quality assurance, and then loaded into the public customer server for customers. So we've tried to bring the Reaxys database, this completion of this database, down to a bi-weekly, every 2 weeks sort of process, updating the database. That used to be one of the main things we heard. It's really funny, actually, though. In 2007, this used to be only updated once a quarter, and nobody ever complained. So it's sort of once a quarter, nobody complains. So then when we get it down to every 2 months, they start complaining that it's not updated frequently. Now we're bi-weekly. So I don't understand that. I think it's just the way that things change. So the excerption of data, why does it take so long, right? Here's a journal article, the citation, the structures, the reactions, what our scientists are looking through, our indexers, our suppliers, right? They've got the title, where the source is coming from, the authors. We're getting the title of the document and the abstract, putting in there for the excerption of the citation, pulling as many of the reactions, exemplified reaction substances that we think are exhibitive of the actual paper itself. Excerption of the compound, right? We start with the structure, find any identification. If it's a 3D molecule, we'll use the ChemAxon Marvin sketch to draw it in 3D and place it in the database so that when you're downloading it as an SD file, the bond lengths and things are there for you to look at it in 3D as well. So the excerption of a compound, the excerption of a reaction, same method, right? We look at the reaction, translate it, use ChemAxon desktop tools to draw the reaction, pull out the reaction conditions, the yield, the solvents, and put that into the database. So a lot of work to actually excerpt a lot of the information and physical facts, the experimental facts, right? So if we find a compound, you'll see it's dark red, we'll put it in the color properties. NMR spectroscopy, if it will note it there, it's a proton NMR, the signals are given. If it's a patent, it's freely available, we'll often put the peaks in as well. This compound has an excerpted mass spec, so we'll put that in there. So a lot of excerption. So in summary, Reaxys aims to deliver immediate access to information. Really when you do a search, what we try to show you is from a chemistry standpoint, relevant chemical things that you can enact on, right? As opposed to a bibliographic list of articles you need to read. Right? We're hopefully presenting you with the facts, with the reactions, the reaction conditions, exported out to a PDF so that you can go back to your work. So this is a good slide of our current interface. So we're moving. What we did, right, we came to this sort of conclusion. We have 16,000 journals and we have 54 million records, but nobody was using Reaxys as a literature searching tool. We also interviewed a lot of chemists and found that a lot of chemists actually start with a sort of a Google type search, right? Preparation of a compound or NMR. So we're trying to make that more relevant to the chemists, right? Using sort of algorithms to promote or to suggest what is going to be the result. So changing that interface, also tied to the fact that a lot of folks don't want to learn this complicated interface. We're trying to simplify this interface as well. Answer these facts, get granular answers, so sort of present that. We also have a Reaxys tree. One of the things that we are coming up against, right, is we have 16,000 journals, right? We only can focus our excerption on 400 core chemistry sort of journals, right, with the manual excerption. By creating a Reaxys tree, which has chemical index terms, we can, Elsevier has a lot of the content, we have a lot of the manpower, sort of the taxonomy know-how to be able to excerpt this not manually, right, through text-based extraction and getting and building our database structures, relevant chemistry facts in there. So that'll be coming up in the future as we sort of fine-tune this Reaxys tree. The Reaxys 2016, again, retrieves relevant answers and anticipates needs. Really, here's a search here where we're looking for preparation of a compound, preparation of, and then it recognizes the search intentions, sort of suggest, hey, you're looking for reactions. If not, maybe you're looking for it in a document standpoint, and then ranking list alternative result suggestions, right? So really trying to ease the burden of showing a user an interface and having them to learn the Reaxys interface to get the results. So with that said, we're going to show you how we're using ChemAxon to do some of the search techniques and then really talk about how the results are presented. Here we're finding substances graphically. As a chemist, I'm interested in substituted sulfocoumarins. Accept these results and then find saturated analogs, quickly analyze the results to find any relationships between functional groups. So a quick presentation. And again, when I do my trainings, I find I'm 70% of the time just showing users how to use a drawing tool, right? And it's not separated, right? They identify Marvin Sketch as Reaxys. So it's sort of embedded, and then I'm having to explain or sort of differentiate a drawing tool within sort of the Reaxys tool. So in this case, right, just looking at this drawing, right, we're looking at any bond, a Reaxys generic group, substitution count of S6. So if I were to try and teach this to folks looking at how to do structure searching and having to explain how this search is going to retrieve the relevant results, it's a sort of a complicated process to just make sure that they understand this. When I go out there, really a lot of my goals now, having taught many of these folks how to search a chemical drawing tool is really just showing them explicit hydrogens and atom lists. It's surprising to me that people just appreciate just atom lists and being able to do explicit hydrogens and doing a substructure search, right? So getting away from this sort of complicated search. But with sending it over, right, finding the substances we're really looking for, does that substance exist? Which properties does it have, right? If it exists, can we buy it? We've got e-molecules. E-molecules has been in Reaxys since 2007 as a partner for available available commercial compounds to purchase. Here we've got our compounds, links, 123 compounds are pulled from 42 documents, and in those 42 documents, that compound, there's 459 reactions, right? And then we can do some filters here. X is in the overall, halogens are in the overall compound, and then find, filter on that, and then find only the structures moving from 123 to 14 where there is a halogen in the overall compound, then being able to export that out. Another example is finding reactions graphically. I'm working as a chemist. I'm trying to find an oxidative cleavage of a carbon-carbon double bond, like styrene, into carboxylic acid is really a transformation search, and using certain reagents and catalysts, right? So as Effie was showing you some of the atom-atom mapping there, and making sure that, hey, you know what, we're not just looking at a reaction search where this is on the reactant side and this is on the product side, right? We're teaching at chemistry, we want that change to occur at that position there, sending that off, doing a substructure search, finding those, finding the transformations. 593 reactions fit in our overall search there. In this case, we're then filtering in on the silver oxide there that we were interested in, and then noting that this is a multi-step scheme. We can click on the view scheme and then see sort of the 4-step synthesis to get to that final product there. So presenting that in an overall synthesis plan for you guys. And then again, that's using ChemAxon Marvin JS to represent those compounds on the web interface. So Reaxys, ChemAxon, Marvin, what the Marvin tools are used for in various ways by our production team in indexing, structure, input editor. It's embedded in our overall sort of product to excerpt and make the database supportive 3D structures. In searching, feature-rich and easy-to-use search powerhouse. In the results view, rendering of the chemical structures and reactions. So that's where we're using the Marvin tools. The advantages, high-quality structure rendering, flexible APIs and integration capabilities, making it easy for us to embed in the web pages. Feature-rich and customizable search options, a lot that as a trainer, we have to teach our folks to get the most out of Reaxys. The biggest one in the last 2 years, it's a non-Java app, moving away from the security issues of having to deploy a Java app and using that with Marvin Sketch, and then comprehensive import and copy-paste features there. So things that we appreciate about ChemAxon Marvin JS. So with that, any questions?
You said that it takes 30 days between when you get a document to when it's available on your website. Are you doing mostly manual curation of all of the various things that you're looking to pull out from a given document?
It's all 400 core journals, and it's all manually curated. So there are thoughts. We're going to implement some automatic sort of indexing. So that's 16,000 journals, trying to at least just get the chemical names in the database into right, maybe using your some of your naming structure to name features. Oh, question.
Yeah, thank you. I don't know if I missed it. Do you have data about things like drug-gene interaction? Is that part of this, or is that a separate?
We have compound and target.
Right.
So yeah, it's the protein target. Yeah, so that is part of it. The Reaxys MedChem.
Okay.
And I probably should have showed that one of the things that we wanted to talk to ChemAxon about was being able to give you guys an SD file or an API. You know, Reaxys has an API, and then passing that along so that then you can do the. What we don't have are the nice post-processing or the visualization. So an example, a customer would ask me, hey, I've done a search on a target. Here's all the compounds that have a bioactivity effect on that target. Now I want to see what are the functional groups that are causing sort of that effect, right? So we don't have those tools necessarily to do that, right? So it'd be great to see how your sort of R group decomposition can help in that.
Okay. And is this extraction manual or automated or a mixed?
It's manual. It's
okay.
still manual for that.